So, as it was mentioned earlier, I'm Rinaldi Sugosh. I'm a software engineer working at IBM Cloud Innovation Lab. I work to develop, as a full-time position, I work to develop the next generation of UI for the IBM Cloud. On the side, I like to consider myself as a hacker in the corporate world. I love to play around with products and just experiment with all the tech that's out there. So before I get started with the presentation, I just want to kind of gauge my audience. How many of you are here because you know what IBM Watson Studio is or the visual recognition services? Okay, awesome. How many of you are like entry-level data scientists just trying to figure out more about data science? Awesome. And how many of you are data science experts in the room? Awesome, cool. Just a clarification, I am no data science expert. I'm also an entry-level developer who found that IBM Watson Studio was a great way for me to get involved and get started with data science. So at a very high level, why is this Watson Studio or visual recognition services so important? Well, everyone wants to work smarter today. If we're a business, if we're an individual working on a science project, the goal is to make smarter projects. When I say smarter, projects that can drive insights, that can drive results, and provide really good user feedback and user insights. And this is really crucial because if 2010 was considered the revolution of, the revolution of smartphones and smart devices, 2020, a lot of people are saying, is going to be considered the revolution of data, where almost every product, every tool that we are going to start using is going to have something to do with data. So in order to work smarter, we need to start tapping into our greatest resource, which is data today. And when I say data is your greatest resource, knowingly or unknowingly, data is constantly collected all around us. If you're driving, it's collected on Google Maps. If you are on your phone, sometimes it's collected on what's your talk time like, and companies collect that kind of data. Financial institutions collect data on what's your user input like, insights on whether you want to get more financial services, how to get you involved in other parts of their companies. And even when you're shopping on Amazon, I'm sure we've all seen our ads pop up on Facebook and be like, hey, you shopped for a sweater the other day, why not shop for a shirt? So data is definitely your greatest resource. And it's also one of the top tech skills in demand. So there's a recent survey out there looking at all the top 12 tech skills, and 6 of the top 12 tech skills had something to do with data science, data visualization, machine learning, artificial intelligence, and so on and so forth. And if you ask me, even UI and UX design, sometimes we're working towards smarter UI, also has to do with data science. And so does cloud computing, because you want to know when your server instances could be possibly down. And in IBM Cloud, we use log_DNA services to find out all the logs, and it's all pure raw data. So what is the problem then? Why is there such a high barrier to entrance into data science, right? And I say this because according to a recent study by Kaggle, there are these 3 challenges, the top 3 challenges for data professionals, which include dirty data, which means that you just have a bunch of raw data that you don't know what to do with, and a lack of data science talent, right? Almost a third of people think there's a lack of data science talent in the industry, and a lack of clear direction with what to do with data, which means that you're not understanding how to put together your data, visualize it, and find insights from it. So for me, when I got started with data, when I took a raw data set from Kaggle, I realized that I wasn't able to identify which tool to get started with, right? How do I drive insight from this mass amount of data? Where do I start? And if you do end up finding the right tool, then you have to start cleaning that data up. Get rid of those unnecessary and unwanted information that's not related to your vision or your project. And then if you get to this step and are successful, the next step would be to try to draw some sort of visualization out of this data to visually represent this data so that it makes sense to you and your end users. And in the end, we are all working towards trying to drive more insights from the data, not only visualize what we have, but also see if we can use this in the future. All of this is great, but you know, it requires three sort of separate tools in my view. One for training, another tool for analysis, and another tool for data. So remember, we need three different tools for three different purposes with the data: training, analysis, and one to store the data. And what can happen is if you're working on an individual project, this might seem quick, but let's say you're working on a scientific research group project, then using three different tools requires integration of these tools, and then you have to drive the cost of how much it's going to take for the data store, how much is it going to take to drive analysis of this data, and further retrain your models if the model didn't train as you intended. And all of this does end up taking a lot of time, effort, resources, and not having this all in one tool is sometimes a very big pain for us as data scientists. So I'd like to introduce IBM Watson Studio. IBM Watson Studio is this all-in-one environment for anyone to pick up, like any individual, any startup, any business, to come in and pick up a data science project, build and classify models, use different pre-built services within IBM Watson Studio, and use them to really help get their project started and maybe even start a proof of concept with the data that they have without using too much resources and too much effort. So I said that it's a very easy to use model, but I think what better way to show it to you than do a quick little demo. So let me get started on the demo. So here's IBM Watson Studio. When you log in, create an IBM Cloud account, log in and look at all the services that IBM Watson Studio has to offer, you will see that you get into a very simple UI that says, hey, do you want to discover some cognitive applications? Do you want to do text-to-speech translation or speech-to-text translation? Or do you want to do a tone analyzer? Or do you just want to do some visual recognition of this huge data set that you have? For the purposes of this demo, we're not going to explore all the tools and services because that would take a long time. So we'll just explore the visual recognition tool. I took the liberty to do some work ahead of time. So I added a visual recognition tool to my application. And when you add a new visual recognition tool, so if you go and look at this new tool that I've added, you can either go into this tool and once it loads, look, you first show up to this page, this introduction page, which has custom models if you already know which data set you want, or if you're like an entry-level developer just looking to use a pre-built model or play around with what is visual recognition, then you can get started with their pre-built general classifier model. So let's get started with that. Let's test this model. So general, it has a bunch of images that has already been trained on, and you can drag and drop any random image and it will tell you what the confidence levels are and what it identifies those images. So I'm gonna drag, this is a apple crumble that's there. I'm gonna drag and drop that. And here, lo and behold, we have some identifying. So if you look at this, this is not all perfect, right? It says that, hey, this is nutritious. I don't know, it's debatable. It's a food, that's absolutely right, with 95 confidence, and then 0.72 confidence, it says it's a dessert, which is also correct. But then we have like these extraneous results where it's like, hey, it could be a crab cake, or it could be a spaghetti bologna. You're like, yeah, I could see how it would recognize it as spaghettis or bologna, but it really isn't that, right? But again, we are using a general model in this case and just trying to see what this image could be. If you notice, I haven't even written a single piece of code yet, and all I had to do was simply drag and drop the image, and I was able to identify what this image, like, I was able to identify the different labels for the image and really drive insights from what I could possibly get from a data set like this, right? Let's further explore some other maybe accurate results. let's try a tennis ball. And this image was a lot clearer. I think there were fewer possibilities with this image, and it identified with 0.99 confidence that this indeed was a tennis ball. And note that we never actually did anything with this model. We just drag and drop these images. And soon enough, we have a visualization. This could be even used for proof of concepts. And if you want to quickly deploy in your own web application. So when I say in your own web application, what if you want this data? Let's say you have a website or a web app that you want to show off some visual recognition, right? Or you are giving a course on it. You can actually use the implementation, so my favorite language, Python. So you can actually just pip install, paste this code snippet, and quickly put into your web application a modeler, a classification, visual recognition modeler. And this way, you will be able to get like the JSON file with all the confidence levels, and you will have, lo and behold, a classifier model in your application. And this is a great way to get started, especially if you are learning about data science and visual recognition. So I've done this with pre-built models. So let's try and check out a model that I just created. Let's see, launch this tool again. There it is. So Austin is a very much dog-friendly city, if you don't know that. Fun fact, I own a dog myself, and it's the best thing ever. So we're gonna classify some few dog breeds and see how it works. So when you usually create a new model, you are given an option to create different classes for labeled data. And labeled data simply means that, hey, I'm saying this image that you're going to train on, this is the label I'm applying to. So this specific image is that of a golden retriever, and that is what it's labeled to. So in the future, when it's trying to identify through its pre-built, when it's training the model, it's going to classify different images under that category. And when you do test the model, as we drop the image, it's going to correlate the label to your image. The negative, as we see, so I have a golden retriever, I have poodles already loaded, but then I also have a couple of negative images. These are images to say, hey, this might look like a golden retriever, but it's definitely not one. So I've trained it with some beagles, with some hounds, and let's see how this works, right? So, and if you wanted, you can always add more classes to help better your model, but you can just get started with this with 10 images. That's all I've trained. 10 images of golden retrievers, 10 images of poodles, and 10 negative images. So, let's go to test the model. And here's some other examples. It tells you I have 10 images that are tested. So let's get started on that. So I have a golden retriever image. And the results say with 91 confidence, 0.91 confidence, that is a golden retriever. And I would say that's a pretty impressive for a classifier. For one, because there's a lot of extra noise, if you would, outside this image, right? There's fall colors, there's trees, there's leaves. And even despite that, it could identify that with 0.91 confidence, this is indeed a golden retriever. The poodle was 0.01 confidence, so that's basically negligible. So let's try a poodle image, since we did train on poodles, right? So very nice looking groomed poodle. Well, it's also with 0.91 confidence that this is indeed a poodle. Note that I had trained on 10 different poodle and golden retriever images, and yet it was able to identify with a pretty high confidence level which one is what breed. And that to me is pretty impressive, right? Without writing a single piece of code. I've just been dragging and dropping. And let's try a doodle. So my puppy is a doodle, a mix of a golden retriever and a poodle. So what would happen? What do you think will happen? Any guesses?
50-50?
Should be a 50-50, right? Yeah, approximately. So when I drop in a golden retriever, golden doodle, it's about 0.53 confidence that it's a golden retriever, but also 0.35 confidence that it's a poodle. Consider that she is a little more golden than a poodle. So that could have skewed the data a little bit. So we've tested so far like the data that exists and the data that could be matched. What about those negative images? So let's try the beagle. So I trained on some beagles, so I'm gonna draw some tests on beagles and let's see what happens. It says, hey, this is definitely one of those negative images. This is neither a golden retriever nor a poodle. I don't know what it is, but it's definitely one of those negative images. So that's cool. And now I wanna do some more extra cases where, you know, the model can get messed up if you don't train on too many images. So let's see if you put like twins, right? Two golden doodles that look exactly the same, then it says, hey, with 0.81 confidence, it's a poodle, and 0.36 confidence, it's a retriever. But if you actually look at it closely, there's a lot of golden fur there, right? Why wasn't the confidence level higher? Did it get confused because there's two dogs there? What happens when you put 5 dogs? So I drag and drop 5 quintuplets on there. And then the model skews over and it's like, hey, I think there's 0.75 confidence I can say those are golden retriever, and then 0.42 confidence that it's a poodle. All of that looks great, but you can tell that you do have to train this model on more images to get more accurate results, right? It should be closer to 50-50, but it's a little skewed because we didn't train on multiple dogs in the image. Awesome. And then I would also like to demo this last image that I have of an Affenpinscher. Fun fact, it's a Affenpinscher. Fun fact, it's a German breed dog and a very cute, very small dog. From a distance, you know, if I was a classifier, I would think that's a poodle, right? Because of the dark fur, the curly little fur. And the classifier also thinks that. The classifier says, hey, with 0.81 confidence, I can say that looks kind of like a poodle, a little bit like a golden retriever, but that's absolutely not true because, and why did it say that, you know, a beagle is definitely not a poodle or golden retriever? Why did it consider an Affenpinscher as a golden or a poodle? Well, for one, I would say we did train a lot of the model for the poodle on black poodles. And secondly, there were no negatives for Affenpinscher. So it was going to draw its connection to either a golden retriever or a poodle. Do you have any questions on this quick demo? Yes? So, yes.
I was just, with this tool, I was wondering if there's any visibility to the classification metrics for your trained models that you're building.
Awesome. That's a great question, actually. So what this tool offers is, yes, it does give you visibility, but to do that, you'd have to actually download the entire code suite onto your local machine. So if you do not want to use pre-built models and pre-built classifiers, you do have to download it onto your machine, and then you can edit those precision metrics.
Software development kit?
Yes. So the question was, is there an SDK that you can use? And yes, there's a wide variety of languages that IBM Watson Studio comes with when you build IBM Watson Studio apps, including Node.js SDK, Java SDK. Those are the ones off the top of my head. I think there was a Ruby SDK, but there's also a Python SDK for sure because data science. Any?
So we saw the example of the testing while for implementation. Is there a way that we can train the model using maybe Python or Java, like using IBM Watson Studio?
Yes. So with the implementation, so if you are not looking into actually adjusting the model, but you just want to continue to train it, the implementation actually allows you to do that, right? So if you want to train, you can actually look at the documentation related to the Python implementation. But if you download Watson Developer Cloud, which is the entire library, it consists of all the commands you would need to code this in Python. So if you didn't want to actually do this in the UI, you could absolutely just download the library from Watson Developer Cloud and do it. Yeah, back there.
Thank you. Is this just, sorry, maybe I rephrase this. Can we have a solution like this that runs on-prem, or is this on cloud only?
Sorry, repeat that question?
Can you run this on-premise, or is this a cloud-only system?
So you can run this, I mean, this implementation, if you run this on a Python script, is on-premise, technically, because if you pip install, you're basically getting the library. And then once you run the script, if you have the modeler already on the cloud, then it will run on-premise.
But you have to have the model in the cloud, right?
Yes, the model is going to be in the
what I
cloud.
was.
Yes,
Thank you.
for sure. Awesome. And then I do have a little more on what other capabilities and tie-ins that it's not necessarily demoable, but other perks that come with IBM Watson Studio and the visual recognition services. So if there's no other questions on the demo, and if you're looking to actually play around and you want like a one-on-one support, I would highly recommend checking out the IBM booth outside. We're doing a very similar demo outside of the IBM booth, and we will help you set up the IBM Cloud account, do a visual recognition service, walk through all the steps, and also any other questions you might have while you're doing the demo one-on-one. So definitely check it out if you enjoyed this demo. So, as I mentioned, it's as simple as drag and drop to get started. So that, for me, definitely decreases the barrier because you can visually see, I'm a visual learner, so you can visually see what is visual recognition, what is text-to-speech, with a simple drag and drop of text, with a simple drag and drop of images. And that is, to me, pretty revolutionary. What about open source tools? A lot of data scientists, I'm sure the data science experts can talk to this, where we use open source tools quite often. Open source tools such as Jupyter Notebooks and RStudio. Well, the good news is they're integrated into IBM Watson Studio. So you can actually run an instance of a Jupyter Notebook or RStudio within IBM Watson Studio and do your data science projects quite seamlessly. What about machine learning and deep learning, right? That's the next big question. When you have data, you've analyzed it, you've visualized it, you want to take it a step further, if possible, if it's the right data. And well, the good news is IBM Watson Studio does support machine learning and deep learning algorithms. And some of the most popular algorithms are very well supported, tested. And if you have a deep learning algorithm that you want to, offload onto your NVIDIA GPU, you can go ahead and do that with PyTorch, TensorFlow, whatever framework you're comfortable using. And as I mentioned before, there are several services that IBM Watson Studio offers. Visual recognition, language classification are just very few. So over 10 services that are pre-built. And if you're an enterprise looking to collaborate, there's a lot more customized services that are offered by IBM Watson Studio as well. And the biggest perk, I think, is IBM Watson Knowledge Catalog. As we know, that is a huge catalog with lots of data sets, lots of examples, example data to back off of, lots of pre-built models and classifiers, as we saw. And it's just a great way to get started, especially if you're doing a proof of concept project or an individual project and don't have enough data to get started. So another question that a lot of small research projects or small projects that start off is, does it scale? And absolutely, it's on IBM Cloud, so it is meant to ensure enterprise level scalability. And along with one of the perks of IBM Cloud being security, it is GDPR compliant, and it is absolutely scalable in the sense that we offer 3 plans. The 3 pricing plans include the light plan, which is, hey, if you're an individual user, feel free to come, run up a server instance, run up a app, and check out the application. If you're a small research project, we've had some universities sign up for IBM Watson Studio. And if you're a small research project, you could get started that way and pay a little bit of money and get some support from IBM as well. And then if you're an enterprise company, absolutely, most IBM services are catered for enterprise level business, and there's a lot of offering, a lot of support that can get started with that. So overall, the three tools that were separate at the beginning for data scientists, IBM Studio kind of combines the three tools, so you can train, you can analyze, you can visualize, and you can even store your data all in one tool in one place, which is amazing because it really streamlines your data science project into one place and also allows data scientists, if they're remote, to collaborate on resources and data science projects. So if you all have any questions, anything that comes up, if you're an IBMer,
please join us in the Developer Week Austin main stage for a keynote given by CTO and co-founder of Unomi, Josh Schulten.
So do attend that keynote. But also, if you have any questions and you're an IBMer, hit me up on Slack at Myrna. If you want my email or LinkedIn, have more questions about Watson Studio, I'd be more than happy to answer. Any questions? Awesome. Thank you so much.